All right, so yesterday we talked about surface areas of prisms and pyramids. We also talked about lateral area. So for a prism, the lateral area was perimeter of the base times the height. For surface area or total area, it's 2b plus pH, or it's 2b plus the lateral area if you already found it. For the pyramid, the lateral area is 1/2 the perimeter of the base times the slant height. And then the surface area or the total area, this time there's only one base. So it's B plus 1/2 perimeter times the slant height, or it's B plus lateral area. We're going to add to these formulas like we did last time. So if you want a kind of running note on your formulas, it probably wouldn't be a bad idea. So for this one, this is specifically a rectangular prism. The lateral area, you can pick your bases. So how many people pick top and bottom? Raise your hand.
That's the only logical one.
Interesting. That's your opinion. Thank you for sharing. How many people picked front and back or right and left? Okay, so I'm going to do top and bottom because most of you raised your hand, but it doesn't mean it's wrong if your lateral area is not the same, okay? As long as your total area is the same. So if I picked top and bottom for my lateral area, then I'm going to do the perimeter of the base, obviously times the height. And we're going to say the base would be 5 times 12, or 5 and 12, sorry, for the sides. So the perimeter there would be 2 times 5 plus 2 times 12. Or 10 plus 24, which is 34. So that's the perimeter of the base if you picked the top and the bottom as the base. And then the height of the prism is 6. So 204, and it didn't give me a unit, so units squared would be your lateral area if you pick top and bottom. Total area would be 2b plus that lateral area, and the b is the base being the rectangle on the bottom would be length times width, which is 5 times 12 or 60. So 2 times 60 plus 204 or 120 plus 204, which is 324 units squared. So again, if you picked different bases, your lateral area is going to be different. That's okay, as long as your total area is still the same. Questions on that one? All right, question 3 and 4 said use the triangular prism. Now still a prism, so still perimeter of the base times the height. This time the base is a right triangle. In order to get the perimeter there, I need that third side. That is a triple 3, 4, what? 5, good. So the perimeter of that base would be 3 plus 4. Plus 5, or 12. And the height of that prism is 20. So this is 240. And then the total area, 2 times the base area plus that lateral area. The base area, it's a right triangle, so it's 1/2 base times height. The base could be the 3, the height could be 4, or the other way around, but it would be those two side lengths. And I get 6. So this would be 2 times 6 plus 240. 12 plus 240. 252 units squared.
So the only difference between LA and TA is that you get the area of the base?
Correct. You add in the area of the base, which in this case there's 2 bases, so they add in the area of the bases. All right, this one says, now you're doing a triangular pyramid. So you've got to find multiple parts here. It's asking for the slant height, the base edge, the lateral area, and the total area. What is given to you is 3 is the measure of K, and K is actually the apothem on that equilateral triangle. 4 is the height of the prism. And the first thing it asks for is your slant height. So again, you've got a right triangle with the height, the apothem, and the slant height. And that again would be 3, 4, 5 because it's a triple. So that one's 5. Then it wants the base edge. So the base edge would be any of the side lengths on the bottom of your equilateral triangle. If you are looking at the actual triangle on the bottom, if you're like looking directly down at it, they gave you the 3 as the apothem, and they want the whole side length. So if we go back to the area of our polygons, because we're going to have to find that base area anyways, I would take my equilateral triangle. I would find the central angle, which would be 360 divided by 3. That's 120. And then I would cut it in half when I draw that apothem in, which means that this angle here is 60 degrees or this angle here is 60 degrees. And it makes it 2 30, 60, 90 triangles. Opposite the 30 would be your A. Opposite the 60 would be A root 3. So if 3 is A, then this side is 3 root 3, and that's half your base edge, making the whole base edge 6 root 3. So a little complicated of a process, but we've done it a bunch of times. You have to, if it's equilateral triangle, and you're given the apothem, use your 30, 60, 90 triangles. Yep.
Are we going to have like a test on this or just a quiz?
You have a quiz and then a test, but yeah, you're going to have both. Okay, so now if I go back to the actual pyramid that's there, this whole side would be 6 root 3, and this part here would be 3 root 3, which is what's going to help you get that last thing it wants as far as the edges, and that's your lateral edge. So the lateral edge is here. Okay, so now I've got to find the lateral edge using 3 root 3 as either the A or the B, 5 as either the A or B, the other one. That would equal your lateral edge squared or C squared. So this would be 9 times 3, 27, plus 25. 52 would equal C squared. C would equal the square root of 52, which is 2 and 26, which is 2 and 13. So 2 root 13. That's your lateral edge. Then you've got to find your lateral area. So 1/2 the perimeter of the base times the slant height. If the base is an equilateral triangle and one side length is 6 root 3, then the perimeter is going to be 3 times that, or 9 root 3. Nope, sorry, I wrote 3 instead of 6. That should be 6 root 3. 18 root 3. And then the slant height we found to be 5. So 1/2 of 18 is 9. 9 times 5 is 45 square root 3. And the last one on this, the total area, there is only one base. I would find the area of that base using my equilateral triangles. So this is 1/2. I can do A and S, or I could find the height of the whole triangle. But we already have the apothem, which is 3. The number of sides, which is 3. And the length of each side, which is 6 root 3. So I would do 1/2 of 6 is 3, and that's 27 root 3. Plus 45 root 3. And since they both have the root 3, we can combine these. 72 root 3. I would say obviously those are the most complicated, like a triangular pyramid. An equilateral triangular pyramid is probably the most complicated if you're finding all those parts too. Questions on that one? Okay, then comes a square pyramid. These are a little bit easier. If you want to draw it out, I start with a triangle in the front and then go back. and make your square, okay? Doesn't have to be perfect. It says the base edge is 4, so each of these would be 4 all the way around. And the slant height is 5.
How do you, oh, it's it.
So lateral area would be 1/2 perimeter of the base times the slant height. If there are 4 sides and each side length is 4, good, 16. And the slant height is?
5.
Good. So half of 16 is 8, and this would be 40 meters squared. The base area, this base is a square, so I would do 4 squared, which is 16, again, meters squared. And the total area would be the base plus the lateral area. So 16 plus 40, or 56 meters squared. Squares are a lot easier, right? Square pyramid a lot easier than an equilateral triangular one.
Are you gonna have to do equilateral triangular one on the quiz?
I don't know the answer to that yet, actually.
When's the quiz?
Wednesday of next week,
Oh.
So is it this lesson and the next one?
and then the one after. Yeah. You mean this one like today's?
Yes.
Yes. Questions? All right, so again, I'll go back if I've got time at the end, I'll go back, but I did post these solutions, okay? They are on the assignment for you to check today from last night. We are going to get into surface area of cylinders and surface area and volume of cones. So we did volume of cylinders already, but now we're gonna do surface area. This is the one that we like skipped in the notes and I'm gonna go back to, hang on. And then the surface area and the volumes of the cones. Okay, we haven't done those yet. All right, so 11.7 again, this is cylinders and cones. So the first is the lateral area and surface area of cylinders. This is the one that we skipped like last week when we got to the point where we were doing volumes and we said we would skip it and go back to it. That's what this, so this is not in 11.7, this is actually from before it, but it will be grouped into your homework. The lateral area of a cylinder, so LA of a cylinder, is 2 pi RH. If you think about it, it would be perimeter times the height, and the perimeter of a circle is circumference, right? And circumference is 2 pi r, so that's where this comes from. The total area or surface area of a cylinder would be 2b plus ph, where b is a circle. So it is 2 times pi r squared plus 2 pi rh. So all you need here is the radius and the height. There's no such thing as slant height on a cylinder. These are super easy, to be honest, if you could just like plug it in. And sometimes they'll ask you to keep it in terms of pi, in which pi would be part of your answer, and sometimes you're going to round it and you're going to use that pi button on your calculator. You just got to follow directions. All right, so example 1 says use the diagram to find. The first thing is the base area. Because the base is a circle, this is pi r squared. Pi, the r is 5 squared, so this would be 25 pi. If it said leave in terms of pi, I'd stop there. If it actually wanted you to get the decimal, I would multiply 25 times pi, and I'd get 78.5. Both of them would be centimeters squared because it's area. That is the area of one base. The lateral area is 2 pi RH. Again, perimeter times height, or circumference times height, which would be 2 times pi times r, which is 5, times the height, which is 7. If it is to be kept in terms of pi, you would multiply all of that out besides the pi, so you'd get 70 pi. And if it wanted you to round it, you would multiply 70 times pi, and you'd get 219.9, both of these centimeters squared.
Why the equation is not 2 pi r squared?
Because it's perimeter, so it's circumference. Yeah. The last one, the total area, surface area, is 2 pi RH plus, well, actually, let me go in the order that's there. 2 pi r squared plus 2 pi RH. Or 2 times the base area plus the lateral area. since we already have those parts on the bottom, I would say use the second one. 2 times 25 pi plus 70 pi. 50 pi plus 70 pi, or 120 pi, which is 376.99, so that bumps the 6 to 7. So again, cylinders are the least complicated of them. You've got to remember the formula, but other than that, it's not like you have to find slant height or anything. Questions on those? Okay, then come the cones. So a cone is just like a cylinder, but with one base. So it kind of is a mixture. It's like a pyramid if the base was a circle. You have the base, which is your circle, which you're going to have the radius of. You have the height of the cone, which is the perpendicular distance from the vertex of the base. You have slant height on your cone, which is along the edge, just like a pyramid was. So there's a right triangle being formed in here by half the diameter or the radius, the height, and the slant height. Usually you will get like either height and you have to find slant height, or you'll get slant height and you have to find height, okay? You need the slant height for the area. You need the height for the volume. So the lateral surface of a cone consists of all the segments that connect the vertex with the points on the base. So if I wrapped it around and didn't include the base, that's the lateral surface. To find the surface area of a cone, you can either find it in parts using the lateral area, which is pi r L. And this is derived from 1/2 perimeter times slant height. How do I find perimeter of a circle?
2 pi r.
It'd be 2 pi r. So 1/2 2 pi r times the slant height. And the 1/2 and the 2 cancel. And that's where this guy comes from. So pi r L is the lateral area of a cone. Surface area or total area of a cone would be one base, so 1b, which is pi r squared, plus the lateral area, which is pi r L. And then again, that slant height is going to run to the top. I actually think this picture is more confusing than it is help. You can kind of ignore it.
Yeah, me too.
Yeah.
Wait, that picture's
What?
picture confused.
Yeah. So ignore it. You don't need it. All right, then volume of a cone. And it is derived from volume of a pyramid. So if the volume of the pyramid is 1/3 base area times height, and the base area is a circle, then the cone is 1/3 pi r squared h. Yep.
You know how the test you gave us, like the little paper?
You'll probably get that same paper. So again, note that for the volume, you need the height, but for the surface area, you need the slant height, just like a pyramid. The easier thing is that there's no lateral edge or base edge on these. It literally is one right triangle formed by the height, the radius, and the slant height. Let's work through some examples. This one says, use the figure to find a base area, lateral area, surface area, and volume. So the base is a circle, which means the area of the base would be, good, pi r squared. Pi, the radius this time is 5. So this is 25 pi. And it would be meters squared if it wanted the unit.
If we don't put meters squared, do we get points off?
No. Lateral area is what? For a cone? Pi r L. Pi, radius is 5. L is the slant height, and that's what's given. It's 8. So this is 40 pi meters squared. If it had told you to round it, this would have been 78.5. And then 40 pi would have been 125.7. Yep.
So slant height is just the height.
No, slant height is the edge, like this on the outside. That's your slant height. Now we have to find, well, when we get to volume, we have to find the height. Surface area, we already have the B and the LA, so I could just use those two. It would also have been pi r squared plus pi rl if I break it down. But the base area was 25 pi, and the lateral area was 40 pi, so this would be 65 pi. Or 204.2 meters squared.
Isn't surface area 2B plus L?
No, for a cylinder, yes. Cone, there's only one base. And then volume, 1/3 the base area times the height, or 1/3 pi r squared h.
How about like, does the slant affect?
It doesn't, but I don't have height. That's where the slant's going to come into play, right? I don't know this height yet. How do I find it? Yep. 5 squared plus the height squared is going to equal the 8 squared. 25 plus h squared equals 64. 64 minus 25 is 39. And the height is the square root of 39, which is 3 and 13. It goes nowhere, so it's going to stay that way.
I mean, square root of 39.
Yep. So then it's 1/3 pi, r is 5, squared times the square root of 39. I'm just going to kick the pi to the end. I'm going to square it and kick the pi to the end. So this would be 25 square root 39 over 3 pi. And that pi could be in the numerator. It could be on the side. It doesn't matter. If it wanted it exact, that's as far as you could get. If it wants you to round, you're going to multiply that out. 25 times the square root of 39. Make sure you close the parentheses if you're keeping it together. Times pi divided by 3. 163.5. Oh, and this time it's cubed, not squared. Because it's volume.
So it is exact.
It's not exact if you round it. This would be exact. All right, again, cone, and again, finding those 4 parts. So what's the difference this time in what you were given?
We're given the diameter.
I'm given the diameter this time, so quick step, but I do have to do what to that diameter to get the radius? Cut it in half, which means my radius is 12. So the base area is pi r squared, or pi 12 squared, or 144 pi. Which is 452.4 meters squared. Lateral area, pi r l. Pi, radius is 12. L is that slant height, which is also given, and that's 13. 156 pi. Or 490.1. Questions on that one? All right, C is pi r squared plus pi rl, or the base plus the lateral area. So 144 pi plus 156 pi, or 300 pi, which is 942.5 meters squared. And then volume 1/3 base area times the height, or 1/3 pi r squared h. This time I have the base area. What I'm missing is the height. What can I do there? That's a triangle. The height, the 12, and the 13. What's the missing side? 5. Good. Triple 5, 12, 13. I promise you, you're going to see triples, so you might as well review them. 5, 12, 13. What? 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, 8, 15, 17. Those are the most common ones. So I'd get 1/3. The base area I already found was 144 pi times the height, which is 5. I can divide this into here, be 48 pi, and then 48 times 5 is 240. So kept exact, it's 240. And 240 times pi, 753.98. So the 8's going to bump up the 9 and make that 754 meters cubed because it's volume. Still good.
So, similar to the test, will the quizzes be multiple choice and the test?
I don't think it's going to be multiple choice, but obviously I'll let you know. I think we've maxed out on multiple choice tests at least. All right, this one. Now we're back to similar solids. So finding the volume of a similar solid. What's the rule on the ratio of volumes? You cube it, right? You take the scale factor and cube it. So this time it's still a cone, right? It doesn't matter what the shape is as long as they're both the same shape. They're both cones. And you have to have some sort of unit length. So the one that they give you this time is the radius. So if I went 3 to 9, that's the scale factor. I'd reduce it to 1/3. And then to get the ratio of the volumes, I would cube each of those and I'd get 1 to 27. That equals the small volume over the big volume. Small volume is 15 pi. The big volume is what I don't know. And then I would just cross multiply. 15 times 27 is 405 pi. And that's the volume of the big one, cone B. If it wanted you to round it, I would do, which I doubt it because they gave it to you that way. It'd be 1272.3 feet cubed. Marsh, did that answer your question?
No, I didn't know I was 55, but I didn't see the pi in it.
Gotcha. Questions on that one? And now composite figures. Sure. Okay, now involving a cone. So this one has a cone and a cylinder. So I'm going to add together the volume of the cone plus the volume of the cylinder. So volume of the cone, 1/3 pi r squared h. And volume of a cylinder, pi r squared h. 1/3 pi, what's the radius on the cone? 3, it's the same as the radius on the cylinder. What's the height of the cone? Okay, so I'd get 1/3 pi times 9 times 5. 1/3 of 9 is 3, and 3 times 5 is 15 pi. So that's the volume of the cone. Plus the volume of the cylinder, pi. The radius of the cylinder is 3. The height of the cylinder is 10. Pi times 9 times 10, or 90 pi. And I get 105 pi. Good morning. You're good. 329.9 centimeters cubed because it's volume. Questions on anything we talked about today? So it does not ask it on this, but this is a great standardized test question. If it had said instead of volume, it said like surface area. So if I asked you to find the surface area of this composite figure, how do you do it? Okay, so that would be the bottom of each of these two, right? So I have to take that out of it, right? Does that make sense? So probably the easiest way to do it would be to find the lateral area of the cone, because that does not include the bottom. Find the lateral area of the cylinder, and then add in one base. So standardized tests love stuff like that, like obviously taking something and applying it, where you'd have to know to take away the areas of those parts that overlap. Yeah. No. Questions?
TV.
Mm-hmm.